I am going to handle process control lab. For that, the introduction will be given. Already I told you that process control is application of control system. Suppose you want to control the room temperature. Suppose you want to control the room temperature means, suppose say you want to control at 24 degrees centigrade, you want to control. It means, what is the first thing we have to do? First thing we have to do what? Let us assume that a cooling system is available. Let us assume that a cooling system is available. That will make this room cool. What is the first thing? I want to maintain at 25 degrees centigrade. What I have to do? First thing? Measure the room temperature. The first thing is we have to measure the room temperature. So we should measure the temperature and then we have to compare this with what value you want to maintain. You want to maintain at 25 degrees centigrade. That is called set point, new term. So most of the terms will be new. That's why set point. So you want to maintain at 25 degrees centigrade means that 25 degrees centigrade is called the set point. This present temperature may be 30 degrees centigrade. That is called process variable, PV, process variable. We have to find the difference between set point and process variable. Set point and process variable. That is called error. You will get error if you subtract the process variable from set point. If you subtract the process variable from set point, you will get error. If error is there, then only we have to control. Suppose 24 minus 30 means minus 6 degrees centigrade. The difference is 6 degrees centigrade. That is minus, it means the temperature is higher than the required one. That's why we have to turn on the cooling system. So to turn on the cooling system, we need a controller. You need a controller to turn on the cooling system. It will on or off. If the difference is, if the temperature is above 24, it will turn on. Below equal to 24, it will turn off. So what will happen? Initially, it is at 30 degrees centigrade. You want to maintain at 24 degrees centigrade. This is time. So it will decrease because it is compared. It is initially it is 6 degree centigrade. That's why it is compared. That's why this controller turn on the cooling system. That's why the temperature is decreasing. Am I correct or not? Time also elapses. X-axis is time axis. Y is actual temperature. This 24 is set point. This is PV. This is process variable. Process variable starts decreasing. But this controller will turn on if the error is negative. The error is negative, then only it will turn on. Let us assume like that. So when just it crosses 24, say 23.9, the actual temperature becomes 24 means equal 0. If it becomes negative, then only it will turn off. Yes. So it decreases. It starts decreasing. When set point equal 24 means the cross variable also comes to 24, then error becomes 0. Suppose the temperature falls below 23.9 means error becomes positive. That's why it is turned off. The cooling system is turned off. What will happen to the temperature of cross variable? What will happen to the process variable? That is room temperature. Now it is 23.9. Now it is 23.9. The cooling system is turned off. What will happen to the room temperature? It will start increasing. Any other answer? Any other answer? Here, cooling system is here. The cooling system means it circulates the air. Am I correct or not? Inside some element is at below 24 degrees centigrade, maybe ice temperature or less than ice temperature, negative temperature. In that, the room air is going there and give away its temperature and comes. It is circulating. What is the element temperature now? Inside element. Some element is there inside that is cooled less than 25 degrees centigrade. Obviously, this air is going there and give away its heat and coming at low temperature. That's why the room temperature is decreasing. Now tell me the answer. What will happen to the room temperature? Hereafter, it is now cooling system is turned off. What will happen? What happens to room temperature? I am asking. Now 23.9. I will put the question this way. Is there any further decrease or not? Here in the cooling system, this is the cooling system, let us assume. Here some element is there. Let it be. That is mechanical system. We need not bother about it. This is cooled down by some circulating system. The room temperature, room is here. This air is going in and a fan is there. That's why it is blowing out its air. Which air it is blowing? Room air is again blown out there. It means it sucks the room air and blows out. So the room air is falling on this. It gives away its heat and coming down, again coming out. That's why temperature is decreased from 30 degree to 23.9. Now the cooling system is off. Why off? Error becomes positive. That's why that controller turned off cooling system. Now tell me whether any further decrease in temperature or not. Huh? Till that element also reaches the room temperature, it will be less than room temperature. That's why there will be a further decrease in temperature. As he said, till it reaches room temperature. This element reaches this element. This element reaches room temperature. Till then there will be a decrease in temperature. So there is a further decrease in temperature. But after some time, as he said, the room temperature and here inside that cooling element also same temperature. Till then it decreases. Then it starts increasing. Am I correct or not? Whenever it just crosses 24, what will happen again? The cooling system again turned on. Am I correct or not? Now what you can expect? Is there any further increase in temperature or immediately it starts decreasing? There will be a further increase in temperature because you cannot expect immediately. Two reasons. One is, as he said, the element temperature is not immediately coming to low temperature. It takes some time. That is one reason. Another reason is the sensor is here. Cooling air is coming here. So it has to circulate this much distance. Till then the room will get heat from all sides. From all sides, it is getting heat. But from only one place, it is getting cool air. I mean, are you able to understand? That's why there will be a further increase in temperature. But after some time, because of that cooling element, starts decreasing. As earlier I said, it happens like this. It oscillates around a set point. Are you able to follow? It never becomes 24. It never becomes 24. It oscillates around set. This type of controller is called on-off controller. On-off controller. This type of controller is called on-off controller. Do you understand this? On-off control. If you put the on-off controller, always it will oscillate around a set point, never settles at set point. What is our aim? What is our aim? We want to settle at 24, but it never settles. On-off controller never settles at, have you seen anywhere that on-off controller? Where? Huh? Refrigerator, AC, where? Any other place? Only on, off. But it never reaches that, whatever the temperature we mentioned, never reach. Maybe less than that or above. Accidentally, it may be equal. Accidentally, it may be equal. And you cannot expect an entire room in the same temperature. That is also there. What is our temperature? 37 degrees centigrade. That's why whatever we excel is at 37 degrees centigrade. Excel is 37 degrees centigrade. That is also there. Okay. Anyhow, if you put an on-off controller, it will not work out. It will not work out. That's why we can convert this controller into a proportional controller. Proportional. Proportional controller means the output is not 100%. Here, the output is 100%. 100% means that this element will get maximum cooling. Say -5 degrees centigrade. Let us assume what is that? -5 degrees centigrade. Its temperature, this cooling element, this blue color, cooling element becomes -5 degrees centigrade. -5 degrees centigrade. Let us assume. But what is the set point? 24 degrees centigrade. We can cool this room by keeping this cooling element less than 24. But if it is -5 means quickly comes to 24. Suppose it is 0 means it takes long time to come 24. If it is 5 degree means it will take further time. If it is 10 degree means it will take further time. If it is 15 degree means it will take further time. So time will increase to reach the 24. Anyhow, if cooling element is less than 24 means definitely it will reach 24. So instead of keeping -5, let us assume that I am keeping from 5 to -5. 5 to -5. I can vary 5 to -5 or 10 to -10. What is there in assumption? Let us assume like that. 10 to -10. Or I can assume 22 because I have to convert it to 24 only. 22, 0. Let us assume what is there. Its temperature can be varied from 20 to 0. So I will make this element equal to 0 if the error is more. Large error means suppose initially it is 30 degrees centigrade. I have to bring to 24. Large error, 6 degrees centigrade. That's why I'll make it 0. It is very close to 24. Then I will make it 20. So small difference. Small difference. That's why there won't be this much difference. There won't be any this much difference. The difference will be like this. It comes to 24 and the difference will be very small, because by the time I made the cooling element equal to 20. You understand that? Depends upon the error. If the error is very small, I will keep 20 degrees centigrade. If the error is very large, I will keep 0 degrees centigrade. So in between all values will come. Suppose if it is the error is 3 degrees centigrade, what is the middle value? 10 degree I will keep. I understand this point. That is called proportional controller. So error varies from 6 degrees centigrade to 0 degrees centigrade. 0 degree centigrade, error minus 6 degree to 0. Because when it is 30 degree, error is minus 6. When it is error is the 24 degree means error is 0. Here, this varies from 0 degree centigrade. If error is 6 degree, minus 6 degree means I will make 0 degree centigrade to 20 degree centigrade. Because I have to keep 25 degree centigrade. Am I correct? This type of variation is called proportional controller. Because the controller output is proportional to error. Proportional to error. What is the controller gain? Error is 6 degree. The change in cooling element temperature is 20 degree. 20 divided by 6, how much? 3 point something. 3.66. Am I correct or not? 3.66. So, if error is 1 degree means the temperature will be 3.66 degree less than this. Less than the 24 degree centigrade. If 6 degree means its temperature will be 0. Because 6 multiplied by 3.66 equal to 20. Proportionally, it is varying. It is proportionally varying. The cooling element temperature is varying from 0 to 20 degrees centigrade. That is called proportional control. Here, large oscillation I noticed. That's why I changed to proportional controller. Actually, I am taking theory because I cannot tell the lab directly. Because you do not know what is PID controller. I have to tell some, I have to tell very short theory. Then only I can explain the experimental setup. That's why I'm telling all these things. So oscillation reduced, but you cannot make set point equal to PV again. Again, you cannot make set point equal to PV. If you use proportional only. That's why here the controller is changed to proportional only, P only. That is called, depends upon the error, cooling element temperature will be there. That is called a proportional controller. That's why I'm putting P. I removed that on-off controller. I removed that on-off controller. I put a proportional controller. Still then you cannot make 24. You cannot make 24. Because how the controller works, controller output equal to, what is the controller output? M, controller output is named by M. M equal to 0 to 20 degrees centigrade. Am I correct or not? Controller output is 0 to 20 degrees centigrade. When it will give 0, 30 degree centigrade. Room temperature is 30 degree, it will give 0. If the room temperature is 24, it gives 20 degrees centigrade. Am I correct or not? Suppose the error is 0. What is the controller output? Error is 0. What is the controller output? Off only. Completely turned off because controller output is 0. Again, it will not make because the controller output is function of error. Error is required to make the controller work. Are you able to follow what I am saying? To make the controller work, you need error. That's why you cannot make error equal to 0. That's why you cannot make error equal to 0. That's why proportional controller also fails. To some extent, it will work. But anyhow, some error will be there that you will study in theory. Always there will be error. Here it is 30 degrees centigrade. Here set point is 24 degrees centigrade. If you put P only controller, it will come and it will oscillate, then it will settle like this. It will settle. Some error will be there. Say 1 degree centigrade. 1 degree centigrade error will be there. It will settle at 25 degrees centigrade. Let us assume 25 degrees centigrade. It never comes to 24. It never comes to 24 because to make functional that P controller, it needs error. That's why it will make 25 only. It never makes 24. Not 25. For example, I am telling 25. There is a calculation is there. At that temperature, it will maintain. But never 24. So P controller also failed. That's why you need some other controller. How to understand that controller? Let us assume that I am driving a car. I am driving a car. Or let us assume that I am driving a car. I want to drive the car at 60 kilometers per hour. I want to drive the car at 60 kilometers per hour. I am giving correct acceleration. Let it be bike or car. I am giving correct acceleration. What is the speed now? 60 kilometers per hour. What is set point? 60 kilometers. It is in my mind. Am I correct or not? Set point is in my mind. 60 kilometers per hour. Car speed also 60 kilometers per hour. What is the error? 0. Error is 0. Suddenly, some road slope is there. What will happen? I am not changing the accelerator. Road is slope, positive slope. What will happen to the speed? Decrease. So what I have to do? I have to increase the acceleration. Am I correct or not? I am increasing. Road slope is still same. I am increasing the accelerator. Again, the speed decreased to 54. Now again it comes to 60. Am I correct or not? Now, road again becomes horizontal. What will happen to the speed? Increase above 60. Another example. Road is horizontal only. I am giving correct acceleration. Suddenly the wind is against the car. What will happen to the speed? Decreases. I am giving additional acceleration. What is the speed? Again 60 kilometers. Again 60 kilometers. Wind is still there. I am giving additional input. Now it is 60 kilometers. What is the additional acceleration given? How much? How to calculate? Mathematically, what is that value? Mathematically, you tell something. How I calculated that additional input? It is proportional to what? I am putting the question in another way. It is proportional to what? That is correct. Which speed? Which speed? My additional acceleration proportional to what? How much it is reduced? It reduced from 60 to 54. I gave additional input based on error 6. 60 minus 54, 6. For that, I gave additional input. Now, what is the error? 0. Error is 0. Still, I am giving additional input. Are you able to follow what I am saying? Still, I am giving additional input. That's why it is keeping at 6 kilometers. That's why this error is proportional to what? Now, the question is, this error is proportional to what? Which error? Now error is 0. This additional input is proportional to what? Now the error is 0. Always the additional input is depends upon error only, not speed. The difference between set point and PV only. The additional input is proportional to what? Old error. It is proportional to old error. So we need a device that will give output depends upon old error. We need a device that will give output proportional to old error, not present error. The proportional controller gives output depends upon present error. That's why for a proportional controller, you need a present error. This controller output is about past error. There is no error now, but earlier there was an error. Earlier there was an error. If you plot that error, how it looks like, how it is looking like, the set point is 60 kilometers per hour. That is set point. The speed is, let us assume, speed is decreased to 54 kilometers per hour. It is decreased. Why? Because of wind. But the controller takes necessary action. That's why it goes up. Again, it goes to 60 and remains at 60. Mathematically, what is the controller output from this graph? What is the additional controller output from this graph? That is proportional. I am putting the error plot here. Initially error up to this point, 0. It goes up to 60 kilometers per hour. I am plotting for error, positive error. This is negative error. So 60 minus 54 positive. That's why it starts increasing this way. This is error plot. This is error plot. This is speed plot. This is speed plot. In the error plot, it increases. I take necessary action. That's why it comes down to 0. Error comes to down to 0. But a little bit oscillation, after that it is settled. From this error plot, can it tell the additional control output proportional to what? From this graph, can it tell? What is this graph? Error graph. Am I correct or not? Because of wind, it deviated and the controller takes necessary action. That's why it comes to 60 kilometers per hour. Sir, not 60 degrees centigrade, 60 kilometers per hour. It came to again to 60 kilometers per hour. Set point. Can you tell the additional controller output proportional to what? I'll tell. Proportional to this area. Proportional to this area. After that, any area is there? No, it is integrated. If you add all this area and calculate, that much input has to be given to the additional input has to be given. That's why the error becomes 0. Once the error becomes 0, is there any area? No area. Till error becomes 0, the area has to be added together. Area has to be added together. That is called integration. If you do integration, suppose this is error graph means, if you integrate that error, you will get area under this graph you will get. If you integrate, what you will get? Yeah, area under the graph you will get. Integration means that is the meaning. You can find, if you integrate any graph, suppose I am having a graph like this. If you integrate this, let it be sine theta. Theta varies from 0 to 180 degree. If you integrate sine theta, d theta, you will get error under this graph. If you integrate up to 360, you will get 0. Why? This is positive, this is negative, getting cancelled. That's why if you integrate sine theta, you will get 0. In mathematics, that's why if you integrate sine theta, that's why you are getting 0. If you integrate up to 180 degree, you get some value. That's why here positive area is higher, negative area is less. That's why you'll get some value. What you have to integrate? You have to integrate the error. You have to integrate the error. So this P mode will not remove the error. That's why I'm including one more mode that is called I mode, integral mode. P plus I controller I'm going to use. P plus I controller I'm going to use. Both mode will be there. P mode will work only when error is there. To speed up the response, P mode is required, not to remove error. P mode never remove error, but I mode will remove the error. So PI controller has to be used. Now we'll come to, that's all about PI. D mode is there, that we rarely we use. In our experiment, you won't use. Anyhow, I'll tell one more mode is called, that's why it is called PID controller. D mode is to speed up the response. Speed up the response. D mode means derivative. This is integral mode, I. D mode means derivative. Integral of E dt means you will get error under the graph. dE by dt will give what? Derivative. What it will give? Physical meaning. What is the physical meaning of dE by dt? What is that is called what? Speed, velocity. Velocity. At what speed the error increases? If the error increases very fast, the controller will give more output. If it decreases very fast, it will give more controller output. If no change, d by dt is 0 means horizontal. Once it is settled at set point, it will be horizontal. No controller output. No need, because it is not changing. Whenever it changes, then only it will work. We won't use. We will use only for slow process. You will study those things later. If I take those things, it will be a theory class. So we have to use a PID controller to control the process, but we will use only P or only P plus I only we will use in the lab. We won't use D mode now. D mode will be used only in thermal process. We are not going to do any experiment on thermal process. That's why we will use P mode or P1, P plus I mode. Hey, understand this? Now we'll come to laboratory experiment.